Alright, so 7.7b, elementary algebra, finishing this problem. This is example 3. And if you remember, we had just factored a 2 out of this problem right here. And we're going to go ahead and make this into two binomials. Two numbers multiplied together give me 150. Added together give me a 5. So that'll be a 15 and a 10, a plus and a minus. Gives me a negative 150. Added gives me a positive 5. So x equals negative 5 or 5. I'm sorry, negative 15 or, God, what in the world am I doing? Negative 5 or 5. Alright, x equals whatever makes this 0 and whatever makes this 0. Alright, notice what we're looking for in the problem. It says, what is the speed? How fast does she ride? Can you go negative 15 miles an hour? No, you cannot. So, that being the case, that number does not work. So, 10 is the only number it works, and that is your answer then. Okay, two more problems here. This next one is a work problem, and it involves several people, and they're trying to do a certain job. So, again, T is time, R is rate, and we'll just see what we've got here. So Allison, she can clean the house in 5 hours. Working together, she and Caitlin can clean the house in 3 hours. How long would it take Caitlin working alone to clean the house? All right, so let's see what we know. Allison, I'll just use A, can clean the house in 5 hours, all by herself. Allison and Caitlin can do it together in 3 hours. We have no idea how fast Caitlin could clean it by herself, right? Alright, so let's use X to be the amount of time that it would take Caitlin to clean the house. Alright? So let's see what we've got here. If Allison, I'm looking at step 1, if Allison can clean the house in 5 hours, then in 1 hour, how much of the house does she clean? 1/5 of the house. Because if it takes her 5 hours to clean the whole thing, in 1/5 of that time, she can clean 1/5 of the house. If Caitlin can clean the house in X hours, then in 1 hour, she can clean it in 1/X, right? The amount of time it takes her to clean the whole thing. So the third part of it says that if it takes 3 hours for both the girls to clean the house, then in 1 hour they can clean 1/3 of the house, right? Okay, so what we did here is we took the amount of time that they can clean the whole house, 5 hours, 3 hours, and X hours. We made it in how much of the house they could clean in 1 hour. So if we took the number of hours, or the amount of house that Allison could clean, plus the amount of the house that Caitlin could clean in 1 hour, that would give you, if they cleaned it together, 1/3 of the house, right? Because together they could clean it in 1/3 hour. All right, so there's my fraction. And what's my LCD? 5 times 3 is 15x. So I multiply. Okay, and this would be 3x. This would be 15. And this would be 5x. And subtract 3x, subtract 3x, so 15 equals 2x, divide by 2, divide by 2. So Caitlin could clean that whole house in 7 1/2 hours. She's a little bit slower than Allison, but 7.5 hours for her to clean the house by herself. Now that one's a tricky one. It's this whole fractional thing that kind of gets you. So follow those instructions when you run into some in the problem set there. All right, so we have one more. It's example 5, and I like drawing the picture. So we have this tank, and we have some water, and we also have another spigot over here. Okay, so water comes out. I love having blue color. I can put my water here, and then I've got water coming out of there. And the thing is, an inlet pipe right here can fill this water tank in 10 hours, while the outlet pipe can empty it in 15 hours. Okay, so some bozo left both pipes open. So this one's open, filling this tank, and this one's open, emptying the tank. So obviously it's going to fill faster than it's going to empty. So what we're wanting to know is, he went home from work, how long is it going to take for this tank to fill all the way up to overflowing? Okay, because this is going to come out faster than this is going to leave. So it is going to fill up, and we're trying to find out how many hours it's going to take to fill that tank up. So the inlet can fill it in 10 hours, and the outlet can empty it in 15 hours. So again, we're going to do the same thing with fractions. So 15 hours, 10 hours. So x is going to be the time, because we're looking at how long. So this is the time to fill with both pipes open. All right. So let's look at each step they give in the solution. The inlet pipe fills the tank in 10 hours. How much of this tank is it going to fill in 1 hour? If it takes 10 hours to fill the whole thing, we can fill 1/10 of it in 1 hour. If the outlet pump or the outlet pipe empties in 15 hours, then in 1 hour, 1/15. Let's see, empty, fill. All right, if it takes X hours to fill the tank with both pipes open, then in 1 hour, it would be 1 over X. So it'd be 1 over X full. Does that make sense? 10 hours to fill it. So in 1/10 of an hour, or in 1 hour, I'm sorry, not 1/10, in one hour, it'd be 1/10 full if it takes 10 hours to fill it. 15 hours to empty it, so we would empty 1/15 of it in an hour. And if it takes X hours to fill it with this open and this open, then we'd fill it 1 over X full, partially full, in 1 hour. So these are our 1 hour filling and empty bits of information. So here's what the equation would look like. If we took 1/10, that's filling it, but we were draining at the same time 1/15, okay, 1/15, then we'd have 1 over X. So do you see why there's a minus sign here? This is full filling, plus we're adding water. This is the amount we're taking away in an hour, and that would give us how full it would be. Okay, so now we find the LCD. So our LCD is going to be the least common denominator. So least common denominator of 15 and 30, or 15 and 10 is 30, and then we have our X. So let's move all this up. Okay, so I said 30x. Okay, so let's start canceling. So we have 30x over 10, which is 3x. 30 over 15 is 2x. And my x's here cancel. So 1x equals 30. So x equals 30. So that x right there is 30. So in an hour, 1/30 of it would be full, which means in 30 hours, the whole thing would be full. So 30 hours is my answer there. And that is the end of the lecture over these. Golly, these are going to be the exact same way. So you've got currents, you've got jobs being done, you've got water tanks empty and all that kind of stuff in the homework. So just follow these examples and you should be fine. And that's it for 7.7.